Welcome to this section on complements of a number system. Let us first understand what is meant by complement of a number system. All digital systems use complement of a number to simplify the subtraction of numbers. So, for supposing we have a number which is in base r. Now this may be a binary system with r equal to 2, or we could have a decimal system where the base or radix is 10, or in a hexadecimal system where the radix r is 16. Now in each of these number systems there are two complements associated, and these two complements are called as the r's complement. That means that is the complement of the same value as the number system. So for example, in a binary system r is 2, so we'll have r's complement as 2's complement, and the second complement is called as the r minus 1's complement. So in a binary system with r equal to 2, we'll have 2 minus 1, that is 1's complement. So we'll have the 2's complement and the 1's complement. Now the r's complement is called as the radix complement because r corresponds to the radix, and the r minus 1's complement is called as the diminished radix complement. Now for a binary number system, as we said, r is 2, so the complements will be 2's complement and 1's complement. This we saw is because we have the r's complement and we also have the r minus 1's complement. So with r equal to 2, we'll have the 2's and 1's complement. In a similar way, for decimal system, r is 10, and therefore the two complements will be the 10's complement, which is r's complement, and the 9's complement. For octal number system, r equal to 8, we'll have the 8's complement and the 7's complement. And for hexadecimal, of course, we'll have the 16's and the 15's complement. So these are the most commonly used number systems in computer science, and we have discussed what are the two complements in each of these systems. Now let us start by first understanding how do we obtain the r's complement of an n-digit number. So let us consider a number. This is a 4-digit number, 2753 in decimal system. Since it is in decimal system, we say r is 10, the radix is 10. Now we will first go and calculate what is the tens complement of this number. So since the number has 4 digits, we say n is 4, and now we'll subtract this number 2753 from r raised to n. Now r is our radix, that is 10. N is the number of digits in our original number, that is 10 raised to 4, and so we have the number 10,000. And so 10,000 minus 2753, that is 7247, and this 7247 is the tens complement of 2753. And now one thing we can observe, that the original number, and our original number is 2753, and when we add it to its tens complement, we got the tens complement as 7247. So let us add it to 7247, and when we add it, obviously we'll get 10,000, and that is the reason this is called as the tens complement, because we have subtracted the given number from 10 raised to the power 4. In general, if we have a n-digit number, let us say that number is d, and we want to calculate the radix complement. So the radix complement is given by r raised to n minus d. Let us compare it with the example we had. We had here r raised to n. R raised to n was 10 raised to 4 minus d, the original given number 2753. But if d is equal to 0, supposing we say that our original number is 0, then the subtraction will become 10,000 minus d, which is 10,000, and we keep only 4 digits from the left, so we'll keep these 4 digits, and we'll discard the one which is on the extreme left. This will give us 0, and therefore there is only one representation of 0 in the radix complement system. How do we obtain the ones complement? Let us consider a number 2753. Here radix is 10 and we will calculate the nines complement of this, that is r minus ones complement. So the nines complement of this will be 10 raised to 4 minus 1, which is 9999 minus 2753, which is 7246. So we can observe that the nines complement of a decimal number is obtained by subtracting each digit from 9. So we have the nines complement of 2753. We can write this as 9999. We took here 4 nines because our original number given to us has 4 digits, and we subtract from this the given number 2753. So basically it is subtracting each digit of the number from 9. So we'll have 9 minus 3, that is 6. This is 4, 2, 7. That is the nines complement. So here is an important result. The tens complement of a number is nines complement plus 1. That is obvious because when we did this calculation 9999, this was 10 raised to 4 minus 1, and therefore we have tens complement of a number is nines complement plus 1. Let us now obtain the r minus 1 complement with a radix point. So we are given a number 26.317 and we want to find the nines complement of this number. So we will temporarily remove this decimal point. We have the digits 26317, and now we'll find the nines complement of this. So we just take each digit and subtract that digit from 9. So we have 9 minus 2, that gives us 7. Then we'll take 9 minus 6, that gives us 3. 9 minus 3 will give us the next digit 6. Then we have here 9 minus 1 gives us 8, and the last digit here 9 minus 7 is 2. So this becomes the nines complement of the number, and now we just put the radix point, so this becomes 73.682. Let us take the other example. We want to find the tens complement of 26.317. Now this is a slightly trickier problem, so let us observe what is happening here. We again see that the tens complement is nothing but the nines complement plus 0.001. So what has happened here is that we must add that 0.001 because the smallest digit that we have here, or the smallest weight that we have here, is 1,000th of a decimal. So we have 1 over 10, 1 over 100, 1 over 1000. And just as in the previous example we were adding 1, let us go back to the previous example where we added 1. Here it is. We said the tens complement is nines complement plus 1, right? But now we have the tens complement is nines complement plus the smallest value there is 1,000th, and therefore that is plus 0.001, and therefore the tens complement becomes 73.682 plus 0.001, which is 73.683. And the interesting part is that if we add the original number to the tens complement, we should get the value which is 10 raised to, and the appropriate number of decimal places we'll have. So 7 plus 3 is 10, 0, this is going to be 0, this is going to be 0, so this is going to be 0, right? So we have a number which is closest to this is in the tens complement. So that is 100.000, because this number is a 2-digit number in the integer part, 26, right? And this becomes our final result as the tens complement. Here let us take an example of a few numbers and their tens and nines complement. Now observe, this number is a 4-digit number. Its tens complement is 4579, and we get this by subtracting. This is our number, tens complement, so 5421 is subtracted from 10,000, and the way we got this 10,000 is we said that is 10 raised to the number of digits we have 4 digits, so 10 raised to 4 minus our given number is 5421. That is how we got the value 4571. And now we know that the nines complement will be 1 less than the tens complement, so we have nines complement is nothing but the tens complement minus 1. So we have 4579 minus 1. Let us consider the next example, 673. Here we have 3 digits, and therefore we will find the tens complement by 10 raised to 3 minus 673. So that will become 1000 minus 673. That gives us this. The nines complement is of course again the tens complement plus rather minus 1. So 327 minus 1, that is 326. Look at this number 900. This has 3 digits, and therefore we will find the tens complement as 10 raised to 3. So this 3 is the number of digits in our given number. So 10 raised to 3 minus 100, that is 1000 minus 100, that is 900. So this part is easy. Now observe this. This is a tricky part. 8, this is our number. Now, although our number is 8, if we want to find the tens complement in 3 digits, we will have to write this as 0, 0, 8. So when we write it as 008, we are still doing 10 raised to 3 minus 8, that is 992. But if we wanted to treat this number as a 2-digit number, then we would have had here 08. Since it's a 2-digit number, we will subtract it from 10 raised to 2 minus this, which is 100 minus 8, which is 92. If on the other hand we treated this 8 as a 1-digit number, then we would say 10 raised to 1 minus 8, which is 2. So the tens complement that we obtain depends on how many digits we want to consider in the original number. So assuming this is treated as a 3-digit number with 008, we have the tens complement as 992, and the nines complement will be 1 less than that, that is 991. Similarly, look at the number 0. This number 0, if we treat it as a 3-digit number, the tens complement is 1000. So that is 10 raised to 3 minus 0. So we are assuming this is the 3-digit number. So we represent it as 000. So that becomes 10,000, and 10,000 minus 1 is 9. So these are the tens and the nines complements. And the radix is obtained by complementing the individual digits and adding 1. So we have obtained all these values in this observation table.